like yesterday, if I gave you, we're going to continue from this thing. I'm going to give you zeros. So if I give you zeros at 1, 2, and negative 3, can you create the polynomial? Is it easy to create the polynomial if I give you those zeros?
Yes.
So if I give you 1, if I give you this, then we know we've got x minus 1, x minus 2, and then x plus 3, right? And then you multiply it out, right? And the trick was we multiply these out, so that's going to give me x squared minus x minus 6, and then I get an x minus 1, and then when I multiply this, I end up with x cubed minus x squared minus 6x minus x squared plus x plus 6. We end up with x cubed minus 2x squared minus 5x plus 6. So I went through that quickly, right? But that's kind of where we ended things yesterday, right? And the complete instructions are, I want a polynomial with integer coefficients. An integer coefficient just means, okay, all your coefficients have to be nice, right? They got to be whole numbers, right? Plus or minus, but whole numbers, all right? That's our goal. So, now, what if I change it? What if I say, how do I make it a little harder? And I say, look, I want zeros at 1 and square root of 3, right? Because yesterday we did a problem. We did a problem where our answer was square root of 3. We had a 0 of square root of 3, right? So I want a polynomial that has zeros at 1 and square root of 3. Well, let's approach this, right? Like, if 1 is a 0, what do we know is going to be part of our polynomial? X minus 1. And if square root of 3 is a 0, what do we know is going to be part of our polynomial? X minus square root of 3. Is everybody okay with that? Now I've got a question. If I multiply this out, am I going to have nice integer coefficients? No, I got a square root of 3, right? That's not going to work. So what I need to do is I need to figure out how, how do I get a polynomial that has all integer coefficients? And the key is, just because I give you 2 zeros, that doesn't mean those are the only zeros. All right? Now, here's the key today. Square roots come in pairs. They always come in pairs, right? And what I mean by pairs, if you've got a positive, if there's a positive, you need a negative. So if the square root of 3 is a 0, what else do you think is going to be a 0? Negative square root of 3. And if negative square root of 3 is a 0, what goes here? X plus square root of 3. Everybody see what happened? Okay? So now my claim is, when we multiply this out, we have nice integer coefficients. And I want to pause just for a second because this sort of came up in first period, and see if I can deal with it now. I just want to make sure we're all on the same page. What's the square root of 3 times the square root of 3? Ends up being 3, right? So you could go through this. Square root of 3 times square root of 3 is square root of 9, which is just 3, right? But really what I want you to know, just in general, I want you to think, well, square root of a happy face times square root of a happy face is just equal to a happy face. Right? Square root of stuff times square root of stuff just equals the stuff. Everybody okay with that part? Okay. So now we go back to our problem. We need to multiply this out, and the way we're going to multiply it out is we're going to multiply these together. Do you see a difference of squares?
Mm-hmm.
And so if this is a difference of squares, what's going to go here?
X squared minus 3.
X plus 3.
Well, this times this gives you x squared, right? Right? And then square root of 3 times square root of 3, what is that going to give us? 3, that's what we talked about. And then it's a difference of squares, so we get a minus. We're okay with this. And actually, just as someone in first period suggested, like someone said, well, why do I need to do this? The only way I'm ever going to get square root of 3 as an answer is if I had an x squared minus 3 as a factor. Like, remember when we set this equal to 0, that's how we got a plus or minus square root of 3. Okay? And let's see, I get an x minus 1. Now when I multiply this out, do you see that I'm going to get integer coefficients, right? So if I get integer coefficients, so this times this is going to give me x cubed, this times this gives me minus x squared, that gives me a minus 3x, and that gives me a plus 3. And so I've now created my polynomial that gives me zeros at 1 square root of 3, negative square root of 3. So, your turn. What if I give you zeros at, let's do 2 and negative square root of 5? So before I hit pause, if negative square root of 5 is 0, what else has got to be 1? Positive, right? Because they come in pairs. All right. So we go through and you think, okay, this is going to be x minus 2, then x plus square root of 5, and x minus the square root of 5. And then how we deal with it is we multiply these together. And at this point, you see that's going to get us x squared minus 25. Is that x squared minus 5? Yeah, we get x minus 5. And then with x minus 2. And now when I multiply it, that gives me x cubed minus 2x squared minus 5x plus 10. This time this is a minus 5x.
Oh, I had to sign that.
All right. That one go okay? So what if we wrap it up a little bit? What if I want zeros at negative 2 and 3 minus the square root of 2? All right. So, if 3 minus the square root of 2 is a 0, what do you think is going to be a 0? 3 plus the square root of 2. And remember, like on your homework, like yesterday in class and on your homework, whenever you use the quadratic formula, you always had like, you could get an answer that's 3 plus or minus the square root of 2, because that's what happens when you use the quadratic formula. So these square roots always come in pairs. See, I have the 3 plus the square root of 2 and the 3 minus the square root of 2. So let's practice writing down, let's find out our polynomial. So everybody okay? If you have 3 minus the square root of 2, we're going to get 3 plus the square root of 2. So that part's not bad. So now let's think about what we write down. Okay, well if there's a negative 2 here, what's going to be here? X plus 2. So that part's easy. And this part, right? So what I'm going to do is give you the full official math way to do it. Okay? See, the official math way to do this is you have to say x minus whatever this is. And this, here I'll close this. And this is, so this is going to be 3 minus the square root of 2. And it's x minus, and this is 3 minus the square root of 2, right?
Plus.
Plus, thank you. Right? And isn't that what you're supposed to do? You're supposed to look at this and say, well, this is a thing, so it's got to be in parentheses, so you're supposed to put it in parentheses, and you put a minus. And this is a thing, so I put it in parentheses, right? Because that's
Why is the second one minus?
well, it's always x
Oh, it's
minus
always-
whatever.
oh my God.
Okay? Now, let's just say then we're going to do a little bit of work here, aren't we? We have to distribute the minus sign. And if I distribute the minus sign, let's see, that's going to give me x minus 3 plus the square root of 2, and that's going to give me x minus 3 minus the square root of 2. Right? Is everybody okay with that part? Because I had to group it and then I distribute. But, because everybody in here would do that because you're all very good algebra students and that's what you do as good algebra students. But let's suppose just for a brief moment that you weren't a good algebra student, right? If you weren't a good algebra student, you would forget to put the parentheses. Like you would forget to put these as parentheses because you'd say, it's not a thing, right? So what would happen if you were not a good algebra student?
Then maybe it's gonna be signs of-
So if you weren't a good math student, then you would say this is going to be x minus 3 minus the square root of 2. And you would say this is x minus 3 plus the square root of 2, right? Because that's what someone who's not good at algebra would say, right? Because they would forget the parentheses. Well, this is kind of interesting because is there any difference between these two things and these two things?
No. Yeah.
They're exactly the same, aren't they? I mean, I multiplied them in a different order, but it doesn't matter, does it? So this is the case, this is one of the few cases where you can not be a good math student and get the right answer. All right? So, let's go back to this. And so I still have the x plus 2. And right now, we're here, we have to multiply this out. So I want to make sure everybody has this written out. Like, make sure this is written out. That's a square root of 2, because my handwriting's awful. And we're going to multiply these two things together. Yes?
If, like, in other math units or like this or whatever, if it's hard or we don't understand, can I come here during your office hours? Like, can you explain it during office hours?
If I've got time.
Okay.
Okay. So, all right. So we have to multiply these out, right? Now you have two options. You could say x times all this, 3 times all that, square root of 2 times all that. But there's a trick. Okay? For the trick, there are a couple of skills I need to make sure that we have in place. Skill number 1. Are we okay that, let's see, if I give you x, are we okay that x minus 3 times x plus 3, can you multiply that easily in your head? Is that real easy? Everybody recognize that's easy, that's a difference of squares? And so we look at this and say, well, that's easy, that's just x squared minus 9. If I were to change it a little bit and say, well, what if it was happy face plus happy face minus 3 times happy face plus 3.
Happy face minus 9.
So it's going to be happy face squared minus 9.
Yeah.
Is everybody okay with that? Actually, what I really needed to do here, what about happy face plus the square root of 2 times happy face minus the square root of 2? What's that? If I multiply those together, what do I get?
Happy face squared minus
Okay. Happy face squared
minus 2.
minus 2.
Yeah.
Is everybody okay with that? Right? Is everybody okay? That's one of the skills I need to make sure you have. Has everybody got that? Does that seem pretty easy? Are we okay dealing with happy face? All right, it's huge, right? Crucial to this. You have to be able to look and say happy face plus square root of 2 and happy face minus square root of 2. When I multiply those, that's a difference of squares. That's going to give me happy face minus 2. Is everybody okay with that part? All right. Okay, the other thing is, if I give you x minus 3 squared, how many terms are we going to get? 3, right? Can we write this out in our head?
Mm-hmm.
Are we okay? Okay, so what's this going to be?
X squared minus 6.
Minus 6x plus 9? Is everybody okay with that? All right. These two things are huge, right? So I'm going to write it down again. So we have this one, and then I have this thing where happy face minus happy face plus the square root of 2 times happy face minus the square root of 2 is equal to happy face squared minus 2, all right? Are we okay with these two? These two skills are crucial. All right, so now let's go back to this, okay? So if we go back to this, when we multiply, here, so everybody's got this written down, right? So here's what I need you to do. Because you've got this written down. I want you to put parentheses around the x minus 3. Everybody should do that right now. Does everybody put the parentheses around the x minus 3? All right. So now when I look at this, I see happy face plus square root of 2 and happy face minus square root of 2. Do you see that? Your happy face happens to be x minus 3 in this case, right? But when you look at this, do you see happy face plus square root of 2 and happy face minus the square root of 2? Well, we know how to handle that, don't we? So what am I going to write here? I can't use happy face. I have to use x minus 3.
X minus 3 squared.
X minus 3 squared minus 2. Is everybody okay with that? Because we're using this skill, right? Or happy face plus square root of 2 times happy face minus square root of 2, right? Oh, we're not quite done. Oh, x minus 3 quantity squared. What is x minus 3 quantity squared?
X squared minus 6x plus 9.
Yeah. X squared minus 6x plus 9 minus 2, right?
Mm-hmm.
And so that gives me x squared minus 6x plus 7.
Can you still?
Oh yeah, we're not done. I want to make sure everybody's okay with this. Okay. Do you see how that worked? Right? Notice how we have these two skills, right? Did those two skills make multiplying those pretty easy? Right? So now we get x squared minus 6x plus 7, and we still have the x plus 2. Right? And so now we're left with distributing this. So when I distribute, this is going to give me x cubed plus x cubed minus 6x squared plus 7x, and then multiply the 2, and get plus 2x squared minus 12x plus 14.
So, sorry, so you multiply the x plus 2 to the x squared minus 6?
Yes. And then you're just, like x gets multiplied times everything over here, 2 gets multiplied, and then combine like terms. And when you combine like terms, we end up with x cubed minus 4x squared minus 5x plus 14. Okay. So, let's try that again. So if I give you zeros at 1, and then we'll do, let's do 2 plus the square root of 5. Press pause. All right, so we get 2 minus the square root of 5. All right, so if we've got a 1, that's going to give me an x minus 1. This, I'm just going to go ahead and write down the x minus 2 plus the square root of 5. And then I end up with x minus 2 minus the square root of 5. Is everybody with me so far? We don't have to worry about the extra parentheses, we just do this. Okay? Now, the trick. What do I put in parentheses?
Or x minus 2.
I'm going to put the x minus 2's in parentheses, right? And then I see, do you see the difference of squares? Here's our happy face, right? And so what goes here?
X minus 2 squared.
X minus 2 squared minus 5. Yes?
What do you mean when you say happy face? Just like the first part of that?
Yes, I'm talking about this, that I put in parentheses.
Okay.
Right? Well, now you got to work this out. Oh, what's x minus 2 quantity squared going to be?
Is what?
X squared minus 4x minus 1. No.
No, plus 4.
Okay. That's gonna give me x squared minus 4x plus 4.
Yeah.
And then I have
Why
minus 5.
Why is it minus 5? 'Cause the-
Well, your difference of squares, that's gonna be a minus. This times this gives you here, right?
Alright.
And so now I have x squared minus 4x minus 1. And I have an x minus 1 here. And all that's left is for me to multiply this out. So to multiply this out, I end up with x cubed minus 4x squared minus x squared plus 4x plus 1. And so I end up with x cubed minus 5x squared plus 3x plus 1. Did that make sense? Okay. Huh.
Wait, did you get the, oh, it's the positive.
All right, well, let's say we have zeros at 3 and 2i. Yesterday, did we have answers that had an I in them?
Yeah.
All right. Well, I is, you can call it like a square root, but it actually is a square root. It happens to be the square root of -1. And because it's a square root, they always come in pairs. I's always come in pairs. So if 2i is a 0, guess what else is a 0? Negative 2i. So if these are your zeros, well, what are the things in parentheses are technically called factors. So if 3 is a 0, what's the factor? X minus 3, x minus 2i. Is everybody okay with that part? Okay, well, we're going to do the same thing. Does everybody see a difference of squares?
Yes.
All right, there's your difference of squares. So when I multiply it, that's going to give me x squared minus 2i squared. All right. Everybody okay with difference of squares? You get this thing squared minus this thing squared. So let's talk for a little bit about 2i squared. Are we okay that 2 squared is 4? All right. Are we okay that I squared is -1? Right? I squared is -1. So this is a 4 and this is a -1, so that all becomes a -4. So now this gives me x squared minus -4.
Wait, sorry, how come the 2i is squared when before the 5 wasn't squared?
Well, it was a square root of 5 squared.
Oh, okay.
And so this becomes x squared plus 4. Now you might be able to get there a little faster than I did, but do you see how this gets to here?
Yeah.
And so I have an x squared plus 4, and this is going to give me an x minus 3. And now I have to distribute this, and this times this is going to give me x cubed minus 3x squared plus 4x minus 12. All right, so your turn. I want zeros at -2 and -4i. All right, so if -4i is a 0, what else is a 0?
4.
Positive 4i. All right, so get a -2, that's going to give me x plus 2, x plus 4i, x minus 4i. Everybody okay? Those are our factors. And the way we multiply this out is kind of like we did before. This is going to give me x squared minus 4i squared. Did you get an x squared plus 16? mean, you can do some stuff in your head, like we know 4 squared 16, that's a
Plus
negative.
not minus.
Well, it's minus, but what's I squared?
Oh, okay.
Right, because this is going to give you a 16, this is going to give me a -1. That -1 makes that a positive.
And how come before we did a negative 4?
There was a minus, but it was a minus and negative, and then it ended up being x squared plus 4.
But for the I, you said 4 times -1.
That is a negative, that gives you a -4, but then it was x squared minus -4, and so we end up with x squared plus 4. I skipped that step. And we have x plus 2. And now we can just multiply it out, and that's going to give me x cubed plus 2x squared plus 16x plus 32. Everybody kind of okay with this? All right. Well, I'll give you zeros at -1 and 3 minus 2i. You have zeros at -1 and then 3 minus 2i. Well, if 3 minus 2i is a 0, what else is a 0? 3 plus 2i, right? Because they come in pairs. And as far as writing our factors, okay, if -1 is a 0, then I'll get x plus 1 as a factor. And if these two are zeros, then I end up with x minus 3 minus 2i, then x minus 3 plus 2i. I'm going to ignore this. Look here. Guess what I'm going to do? What am I going to put parentheses around? Ah, y'all are good. You see our x minus 3 is the happy face?
So if there wasn't a 3 in front of the 2i, it would be x minus and then 2i, and then it'd be x plus 2i. 'Cause
Yes.
sometimes it can be plus, I don't know.
Yes. So far, so good? And so now this is going to give me x minus 3 squared minus 2i squared, right? So the x minus 3 squared gives me, when I square this, what am I going to get?
X squared minus 6x
Plus 9. And let's think about what happens here. 2i squared gives me what?
4. -4.
That gives you a -4, doesn't it?
So plus 4.
So this is technically a minus -4, right?
So it's plus 4.
And so now this gives me x squared minus 6x plus 13. And I get an x plus 1, and now it looks like all the other problems. When I multiply it out, that gives me x cubed minus 6x squared plus 13x plus x squared minus 6x plus 13. End up with x cubed minus 5x squared plus 7x plus 13. Everybody kind of see how that worked?
What is that number?
13.
No, next to 13.
7x. It's 13 minus 6. Okay. And normally I would give you another example to work through this, but I also want to